Hello and welcome. We'll be naming molecules today, specifically binary molecules, meaning there's two different elements in the molecule. So by the end of the video, we should be able to come up with an answer to this question. How would we, with these two different molecules, come up with two different names so we wouldn't confuse them with each other? Like each of these molecules have carbon, represented in black. Each of them have oxygen, represented in red, but we can't call them both carbon oxide. This is carbon dioxide, all right? This is what we breathe out, all right, and that trees take up and all that. And this is carbon monoxide, which of course is the deadly one, all right? So we need a way of having a system to name these differently, in a way that everyone can understand. All right, so the conventions will be following. You don't necessarily have to write this down, but we're following IUPAC, the International Union for Pure and Applied Chemistry. Okay, it's an international group where people from all around the world agree to a naming system that we can all use for naming chemical compounds. All right. So we're following IUPAC. All right, so this is what we're going to do for molecules. Again, we're working with molecules, which means non-metals only. Let's get a periodic table out right now just to make sure we're on the same page. All right, so we can draw the line for metalloids, and everything to the left is going to be metals left of the staircase, which means in this video we're not talking about them. All right, we're talking about elements bonded together on the right side of the staircase. And before you're like, oh, well, isn't there some exceptions and nuance to this? We're not getting into that level. We're trying to keep this basic and kind of a 101 level. All right, so let's go. Here is the template we need to use to name binary molecular compounds. Okay, we got 6 things to do, and so I got them in order. Okay, thing number 1, 2, 3, 4, 5, 6. First thing, prefix. Second thing is going to be the name for the first element. The third thing is going to be to place a space. Fourth thing, a prefix again. Losing track of things. Fifth thing will be the name of the second element, and then the sixth and last thing is to change the ending of that second element to an "ide." All right, so those are the 6 things to do. As for prefixes, we're just going to stick with 1 through 10. If you have only one of the first element, you're not going to give it a mono prefix. That's why I have it crossed out there. But any other prefix, yes, go ahead and give it. And for the second element, it always gets a prefix, even if it's mono. All right. So there's corny jokes around this, like the first element doesn't want to catch mono or something like that. But the second element did. Whatever. Whatever helps you memorize stuff. And that's the template. So let's just dive into examples. All right. We're gonna go. First do formulas to names, then we'll do names to formulas, and then we'll close with some elements with wrong names and trying to fix them. Okay, first off, when we're following this template, we're gonna just stick with this order. You may have some sort of questions like, what element should I be naming first? At the Chem 101 level, at least when I teach this class, I try to take away that guesswork from the students, and I just tell them to list things in the order as written. Okay, so like CO, carbon, oxygen. Carbon would be your first element. Oxygen would be your second element. All right, I'm not going to have them play games of like, was this written in the right order or not? I'm not too interested in that. That being said, though, if you are interested in how that order is chosen, the IUPAC rules is to choose typically the leftmost element followed by the rightmost. Okay, and that, another way of thinking about that is the most electropositive element, like a metal, followed by the most electronegative element. So we're kind of going up and to the right, generally speaking. And in fact, they have a diagram for that on their website. You don't have to necessarily write this down. They have like arrows and everything. I think I have the real one somewhere. There it is. Their arrows go like in the opposite direction. But for me, I like this direction. And so it's kind of like, so I'm starting with carbon, nitrogen, and then we have hydrogen randomly here. Oxygen, okay. But basically, you just kind of go up and to the up and to the right for your kind of your flow of element order. All right, so with that out of the way, let's just get into examples. All right, so first up, we have carbon and oxygen. We have one carbon and one oxygen. So we're going to say carbon, and then one oxygen, we will say monoxide. Okay, maybe you thought it should be monoxide. But if you have two vowels next to each other, especially if it's the same vowel, you can just go ahead and combine them. All right, so carbon monoxide. Don't put monocarbon monoxide because we don't put mono for the first element, even if it is a mono. All right, so that would be this molecule, carbon monoxide. All right, one carbon, one oxygen. Here we have one carbon, two oxygens, CO2. Remember, in chemistry, if you don't write anything, it's a 1. But we don't write 1s in chemical formulas in chemistry. So this is CO2, carbon. Let's go to our prefixes. Dioxide. And it's not bioxide, like Bi. That is, in some contexts, also a prefix for 2, like in a bicycle. But in chemistry, we don't do Bi when it comes to the number 2 in when we're naming stuff. Okay, so we use di. All right, so carbon monoxide, carbon dioxide. I love these two examples, because if I'm suddenly drawing a blank of how do I name compounds, I always think about carbon monoxide and carbon dioxide because we use those actual names in everyday life. All right, next one, we have oxygen. And then 2 chlorines, so we go dichloride. All right. And lastly, let's go through these. All right, so we got one nitrogen, one oxygen. Nitrogen monoxide. One nitrogen, 2 oxygens. Nitrogen dioxide. 2 nitrogens, 1 oxygen. So that's going to be dinitrogen monoxide. Okay, this has a nickname of nitrous oxide, or a trivial name, what do they call it? Alternate name. All right, this is the laughing gas used in dental offices. Okay, when people do like street racing, they get that NOx mixture. I think it's a mixture of like these two or something. NO is a hormone, nitrogen monoxide. N2O5, this is something different. This is dinitrogen pentoxide. Like if a student wrote pentoxide, I'd probably give full credit. But like the A and O, you just combine it into an O sound. And I guess O wins the tug of war for which syllable vowel wins out. So dinitrogen pentoxide. All right. Next page, let's go names to formulas. Sulfur hexafluoride. Okay, rest in peace, James Earl Jones. All right, at the time of this filming, he died a few weeks ago. I think this is sometimes like nicknamed the Darth Vader gas because if you inhale it, it'll make your voice sound way deeper because it's like a dense gas. Kind of an opposite effect of like helium gas, where it's less dense than air. I'm not encouraging you to try that. Usual disclaimers apply. If you're going to try that, make sure you don't do it so much and cause yourself to not have oxygen. But anyways, I do want to try that someday. I think that'd be pretty fun. Boron trihydride, BH3. Tetraphosphorus decoxide. Tetra, so we're going to have four phosphoruses. Decoxide, so 10 oxygens, P4O10. All right, and then last page. Hopefully this video is a little on the shorter side. What's wrong? So someone wrote hydrogen sulfide for H2S. Okay, while I will, first I want to say this is a common name that is typically accepted for H2S. In everyday language, people just say, oh, hydrogen sulfide gas, and that's totally fine. But if you were to follow IUPAC rules, then this would be dihydrogen monosulfide. All right, and then next one, monooxygen monochloride. Looks like someone's trying to come up with naming that sort of compound. So like we can figure out from that name that they probably mean this. But first element, if it's a mono, you don't write it. So that would be the correct formula or correct name for that formula. So, all right, that's molecules. And up next for naming, we're going to get to ionic compounds where you have a cation, typically a metal cation, and an anion. All right, take care.